for us today. It is lab. So I will just describe what we would supposed to do in the lab and what you are expected to do from this lab today. All right. So if you cannot hear me, please speak up. Don't just type, because if you type, the message will come and then I will see. I don't know when. If I have time, I will see, because I'm on the other page, so I don't always see these messages. So yeah, for this today, analysis of vinegar. And as we know that vinegar, I'm sure that all of you know, vinegar is an acetic acid, right? This is an acid, which is an organic acid, it says, and it is a weak acid although, but it is acid nonetheless. So since it is an acid, how do we determine or quantify it, how much of that acid is in the solution? So the easiest way is to do it by titration. And if I am also sure that you have done titration in your high school or pre-uni before you come here. But if anybody has any, want to refresh your memory or want to refer back what is titration looks like, or how the titration work is actually carried out, please go and check with the acid-base titration. The link has been provided already under week 2 module on the Canvas. If you click on the link, it will bring you to a YouTube channel, and that YouTube channel explicitly nicely is telling you what is titration, how to do the titration, what is the technique for doing titration, and all those things. However, titration is the practice of doing the titration that it will show you in the video, but there is some other calculation associated after the titration done to quantify, to know how much is the acid is there, right? If we do the titration, from the burette, the titer is coming to the titrant. There's titer and titrant. That's different thing. You can see from that the video on YouTube as well. But coming, and then at the end, the titration is done. When the titration is done, because the indicator, chemical indicator for the titration, we need to use a chemical indicator. When the chemical indicator changes its color, right? It can be colorful or from color to colorless, or it can be different colors. So when the chemical indicator changes its color, we know that the titration has been done, finished already. Okay, so after the titration done, how much of the acid or base I used into that titrant, right? How do I know it? So that is some calculation associated. And you might be wondering that what you are supposed to do for this. You have seen that I have divided you into 13 groups. There are 13 groups, quite many students actually. So there are 13 groups, and each group of you have 3 students, right? One group has 2 students only, but other groups has 3 students. For every group, I will provide you the data right away after this tutorial class. Okay, by 4:30, hopefully I'll be done. 4:30 Malaysian time, I'll be done uploading those data to your groups. So you please go to the group, on Canvas, you see the laboratory group, you go there, you will see that your data is there. And bear in mind that those data, all the data will be given there. It's different from others. So if you just copy your other friends, I will know that you just copied, your answer is not correct. Okay, so you cannot copy. First of all, it is a very bad practice. Second, if you copy, then there is some punishment for it associated. So do not copy. And if you copy, when I read one after another your report, I will know that, okay, this report is very similar to that student who's reported, and then I can check back. So both will get reduced mark. Okay, I'm not going to, I'm just telling you that this is the practice that we do here. Another thing is this lab report is individual. Okay, everyone, all of you individually has to submit this experiment 1. Okay, experiment 1, everyone, all of you has to submit, not by group. If it is group, I will tell you that okay, you submit this lab report per group, but for this lab experiment 1, everyone has to submit. It's clear, I hope it's clear that every one of you has to submit this lab report individually to the link. It will be open, the link will be open by next week, when before this next lab, the link, the due date. And through this link, all of you individually, or only your report you will submit, only your report, not for your group members, not for others, only your report you will submit. Okay, let's go to the lab work. What is the lab work for today? This is the lab. All right, this is I don't know to which group I will assign it, but I will upload this lab to one group. So what will happen is, can you see? You cannot still see it yet. Can you see that I'm showing the Word file? Hello.
No, we can't see.
Oh, you can see. Okay, good. Thank you. So now this is, you write your name here, your student ID, your laboratory group.
No, I said we can't see.
You cannot see?
Yeah, I can't see.
Um,
I can see now. I can see it now. I can see it now.
okay, all right. So the thing is, this is the cover page for this. I will give you this Word file so that you can type, or if you choose, you can just write by your hand, up to you. But when you write your hand, you can write, it's okay, and then just take the photo, right, with your hand phone. After you write it on, show you, like you write it on the paper and then on by hand, and then take the photo and make it PDF as one file, all the pages together as one single PDF, and then upload it. I'm okay with that. But if you write by hand, make sure that your handwritten is clear, okay, and that I can read. If I cannot read, then I'm sorry, I cannot give marks, right? So this is the number one, name. First of thing, you should write the name here. Your student, don't forget, please write your name. You should only on the first page. No need to write on the other pages as any other page. Only on the first page, on the cover page, write your name. This is for all the assessment. All right. You submit your lab report. You submit your assignment. You submit your group project. You submit your final exam or mid-semester exam. Please write on the first page. Okay, just name on the first page. Your name and ID both together. Group number, name of the group, your practical group 1 or practical group 2, whatever. Date you can write, or it's optional actually, not necessary, because it will be electronically submit. So if you are submitting late, then I already know that you submitted late. Okay, so this is what your marking rubric and what you should do to get a good grade, what you should write or how you should prepare to get a good grade. Data recording must be, requirements. There is no good or bad for data recording. I will not talk about this rubric after this, okay, because the rubric is similar for all other labs. So for data recording, you should be, the data actually for this case is I am giving you, so there is no thing, all the data are recorded, I am giving you. And data analysis, you should show me the data and every step of how you do the calculation. you do not jump, okay? Don't jump that, don't assume that everybody know and you can jump few step and go to the directly to the answer step or result. Please show, it does not take much, just show all the steps that, okay, from this number of mole is molarity, then number of molarity. I mean, as an example, from molarity to this mass or molecular weight or total volume required, all that step by step you show us. And of course in clear cut way. And also when you are writing this, make sure or be careful about the significant figures. I'm not sure whether you are aware of the significant figures, but I am just going to show the significant figures right up now after I talk about this. Okay, significant figures. And if your significant figures is not very, consistent, then you are losing marks there. Also, discussion. So what we get, how do we do, the methodology is already there, that how you do that, the methodology is already there, but the discussion, you also tell us that why the result is like this, why the result is good, or is the result is bad, or is the result is, acceptable within the range, right? Or what are the errors? What could be the error, right? There are many possible error can happen, like instrument error. If your instrument is not calibrated or it is not clean, right? Or you do not use it in appropriate way, then there might be some error occurs. There may be some unavoidable or error, that is the instrument that you are using, although you have done the calibration, but due to that the light differences, the light that you cannot see properly, the fluctuation of the light, fluctuation of the voltage, right? You are using a electronic balance or electronic some apparatus, and the voltage is fluctuating. That is not beyond your control. You cannot control. So even by that, there will be some error. So those are the errors that we cannot control. So you mentioned, you try to figure out what was the error behind. Or sometimes if you, the student, or if those guys who is doing the experiment is very not sincere, right? If he or she is not sincere, there might be a big error, and that error is not acceptable, right? If you have error like this, fluctuation of error, this type of error, and those can be minimized or can be acceptable. Okay, this is beyond our control. But if anybody is lazy or not professional way or not proper way, is not following the procedure, that is not acceptable. So those are the other source of error that can occur. So instrumentation and the personal error, both. Okay, so you need to identify the sources or tell us what could have been the error behind this result that has been swayed or not accurate. So those are all those things will be in the discussion. Right. Now let's come to the experimental analysis of vinegar. As I said, that vinegar is an acid, a very weak acid, organic acid. All organic acid are weak acid. And then I want to quantify it to know the amount of vinegar that I have in that through titration. Oh, by the way, if you are not very much familiar, I am assuming that you know already titration things, but you are not very familiar, or you need some you need some you need to freshen up your knowledge, then we are going to talk about the titration volumetric method. Actually, titration belongs to the volumetric method. We are going to talk about it in the next Monday, next lecture class. If you, I mean, those who have already searched or explored, they already know that it is under the week 3 lecture lecture. So we are going to talk more about this titration thing on week 3 lecture during the lecture. So just here for your information that sodium hydroxide is a base and it is a strong base, right? It's a strong base. So we will add this sodium hydroxide to neutralize this acetic acid. Neutralize means this acetic acid is no more acid. The sodium hydroxide is no more sodium base. So they will produce as water and salt. And by the end of the reaction, they will produce water and salt. There is no more acid or base left. So that is the neutralization. At the end, how do we know it? Because we will use indicator that is for this case is phenolphthalein, and phenolphthalein will change its color to pink, right? From the colorless to pink, it will become. So after this, we will check that how much, because we need to find out the concentration or amount of acetic acid, right? The concentration or amount of acetic acid in the solution. So the acetic acid will be in the conical flask, right? It is in the conical flask, and the sodium hydroxide will be on the top, that is in the burette. So that is the titer. Sodium hydroxide is the titer. This is the titrant, right? So we put drop wise from the burette, and then we at the end we see that how many milliliter of sodium hydroxide I used it, right? So from there, I know that how much of sodium hydroxide, how many milliliter of sodium hydroxide I had to use, or at the end, how much I used it. And then the sodium hydroxide, I prepared the solution, right? We prepared the solution in the lab, so we know the concentration of the sodium hydroxide. And since we know the concentration of sodium hydroxide, and we also know the volume of the sodium hydroxide is used through the titration, so we easily know the number of moles of sodium hydroxide, isn't it? Right? So the volume and the concentration. So N equals C times V. So concentration times the volume, if we multiply these two, we will find the number of moles of sodium hydroxide. And, oh, sorry, I forgot. Yesterday we were talking that every reaction we need to balance it first. So luckily this reaction is already balanced and it is 1:1 reaction. So we do not need to balance it anymore, right? So if since it is 1:1 reaction, the number of mole of sodium hydroxide will be in this titration process is exactly same amount of acetic acid, the number of moles. The number of moles, whatever we found for sodium hydroxide, is exactly same as for this acetic acid. The N is same for the acetic acid. And if we know the acetic acid number of moles, and we have the volume of acetic acid, right? That 10 milliliter, 20 milliliter, whatever milliliter you have taken is from this, you read the description is given, I forgot. So whatever volume of acetic acid is given there, from that volume, we already found that, okay, this number of moles is this, the volume is this, so what is the concentration? Because concentration is mole per liter. That is also, we will talk about it on Monday. So mole per liter is the molarity, right? Is the molarity of the solution. So from there, we can find out the number of molarity of the solution. Okay, so if it is molarity of this, and then from, if we find the number of moles, of course, then we can find the gram as well, because if we find the number of moles, then we from this molecular weight, that is gram per mole, right? That's gram per mole. If we multiply with this, the number of moles with gram per mole, that is molecular weight, we'll find the gram. So you have to try it on paper. Otherwise, it will be a bit problematic to follow. But I hope that I'm giving you a good insight, or you can later you can reflect on it. So we can find the weight from the number of moles, or molarity, of course. From number of moles, we can find the molarity. From number of moles, we can also find the how much of the mass of it. So since we find the number of mass of this, we can also find the weight percentage, that is mass of acetic acid by the mass of solution and times 100%. That is the ethanoic acid or acetic acid's weight percentage. And every group will have different weight percentage. So every group will have different the data. So you cannot copy. If you copy, then it is wrong already. And if you even copy from your group members, write on your own. Okay, write on your own language. Doesn't matter what you think. You just write it in your own language, right? And then don't copy from others. That's the most important thing. Okay, so here in the calculation part, you will write, I was just talking about it, the calculate the amount of sodium hydroxide, the moles of sodium hydroxide is here. And this is for number 1. Okay, for this number 1, here we will find the titer. Titer is the difference of sodium hydroxide, or that is the titrant, and the titer is used. Okay, the titer is used. In this case, titer was sodium hydroxide that is coming down from the burette, coming down from the burette, right? That is the titer. So we cannot do only one run. If we do one run, that is a very big mistake. At least we should do 3 runs in the lab, 3 runs, and we will see that if the results are close to each other, if the results are not close to each other, or less or similar, or moreover, like the difference is 0.1 milliliter, okay, from one reading to another reading, then it's okay. But if it is the result, the reading is from one to another one is more than 0.1, then the result is not good. That run is not good. I have to do one more run, because probably there was some problem that I don't know what problem. So that's why at least 3 runs are done, so that if we get the 3 consecutive results or very close to each other, then that is good. All right. So here, usually we do 5 in the lab. So I give you data for 5. And you will find the difference, like 48.4 minus 23.1. Okay, so this is the difference. I do not know, you can calculate it. And 46.7 minus 23.6. So here will be another difference. So in this way, you will get 5 different results from that difference of the titer, right? 5 difference. And out of these 5, we will take 3. We will take 3 results to 3 of this reading to make an average. We will not take all. If all the 5 are very close to each other, we take all 5. If there are 4 very close to each other, like the difference between these 4 is less than 0.1 milliliter, we take 4. But at least we should have 3 different results that is very close to each other. All right. And since the data is provided here, it is not from what we get from the experiment. So the margin is increased. So if the difference is less or equal to 0.2, 0.3, then it's still acceptable for this case. Okay, so you should take do the calculation here. Take the reading and take the close result. Tick the close result. If you are taking this result to do the average, tick here. If you are taking this result here, just tick here. And if you are taking this result, then tick here or anywhere. Just tick, tick, tick that you take this result, this result, this result, this reading. And with this reading that you are taking with or ticking, you do the average, calculate this one, all those sum of the result divided by the number. Okay, so that is the average, and that average is actually considered for the volume for sodium hydroxide. So for this first one, we know what is the volume of sodium hydroxide was used. That is the average volume, the amount of ethanoic acid, number of moles, because the number of moles will be same. And the density is 1, so D equals M over V, right? D equals M over density equals mass over volume. So we know the volume of this, and now we also know the density, so the mass we can find out that if 10 milliliter of the ethanoic acid or acetic acid, what will be the mass for this? So from this, and express it is in two significant figures. So okay, I'm going to the significant figures now. So anyone has any question about this? Is there anyone has any question? So should all the submission be in PDF? Can we submit in Word file? Yes, you can submit in Word file, but I prefer PDF, because if Word file, my laptop, I use WPS, my office computer, I use Word file. So sometimes it changes, sometimes, and because sometimes there are this table, the table is very problematic, it's break apart, and it is very problematic, it's troublesome. So I prefer, if you please submit it in PDF. It's easy, right? You just, from Word file, you just save as PDF, and then you upload that PDF. It is easier for me as well. Another question is, how should I know which team I will be? You please go and check on your Canvas. You are already been assigned to a group. You don't have the choice. I did it because it is for the foundation students. We do the grouping. Foundation student cannot do by themselves. How should I know? Okay, all right, sure. Can you check from your Okay, yeah, thank you, Marjan, because I think you are telling to your friend, does each member in the team has to submit it? Yes, very important. I think you joined a bit late. Every single member, every single student individually has to submit this experiment 1, okay? Experiment 1 has to submit individually. Yes, you discuss, please. You discuss how to do it and then help each other, but write in your own language, own word. Okay, so what I was going to tell? Oh, experiment 1. Please submit each, for this vinegar, everyone individually. Probably second, third, I will make it per group. So it will, your workload will also be reduced. It will be easier for you. I just want to know that you know how to do it or you try to it. And another thing is what I was going to tell that. Okay, I forgot what I was. Okay, when is the due date? The due date always for all the experiments. Just listen up. I'm not going to repeat this again and again. All the experiments, the report is due just before the next experiment starts. So from today, next Tuesday, before next Tuesday, that is Monday, by next Monday, 12 a.m., let's say, if you want to submit at the end, last moment, you can, but if you submit at the last moment, there might be some problem and I'm not there to help because at night. So don't wait till the last moment, but the due date, it will be open from now till next Monday, every week. Just before the next lab start, the due date will be before the next lab. All right. Okay, so is there any other question before I go to the significant figure? We type in the Word file or we insert images. What do you mean? Who is it? 10122349665. Your name is not showing, so I do not know who it is. And okay, like we write on A4 paper. Why do you have to do that? I think typing is much easier than inserting the photo in Word file. But yes, you can do that. Make sure that it is nicely oriented. The original, do not change the original file, okay? Do not break or delete the original thing that is I'm providing you. Please do not delete it. You can take the photo and insert it and then convert it to PDF before you submit. I think I will just allow you to submit PDF. The option will only be to submit PDF so that everybody knows that it is the PDF. Okay, what the marks? What's the marks? I already. Please go and check on the unit outline for lab. We have 15 marks, right? 15 marks for the 9 labs. We have 9 labs, 15 marks. Till now it is 9 labs, so 15 marks. So if we divide 15 by 9, it will be 1.5 or 1.66 or something, right? 1.67 marks per each lab. If the number of lab is we cannot conduct or it is reduced from 9 to 8, so the marks will be evenly distributed to all of them. All right. Print it out, the file. Brian Key, print it out, the file. What file? What printout? Brian, I didn't get your question, so I'm sorry. Can you clarify a bit? Brian, if you're listening, I did not get your question, so you need to clarify a bit so that I get it. Okay, so now like print this file and write as in. Yeah, no problem. And then you submit it as a PDF, like take photo and make it PDF, or scan it and submit as PDF, also okay. But the thing is, that's what I'm saying, that you can write by your hand, no problem. But make sure that it's clear that I can read. Because sometimes students write so small, it's so easy. It's so difficult. Reading glass, sometimes the magnifying glass, it's not easy to read. So don't make our life more difficult. Okay, so now I'm going to the significant figures. Okay, so here we are. Can you see? I hope that you can see. Okay, so okay, significant figures, and here it is the what first of all, we during the calculation or experiment, we encounter different level or different range of data, right? Sometimes we get, okay, 1, sometimes 5, sometimes 50.555, like that. Usually that digital meters, they give you a very fine number, 0.55, 0.222, 0.235, like that. So what should we do with this? For calculation first, I don't need to tell you, but I just as a refreshing that when we are doing calculation, right, we have to make sure that the units that we are using are compatible. That units, if we are adding, we cannot add gram and liter and moles together, right? All has to be in gram. If we are multiplying, we have to make sure that this gram and volume, that they also, translate, or they also give us some idea about the final result. We cannot just take any unit and then multiply it, right? So this is one thing, first thing I want to tell. And the second thing is significant figures. That is, I am on the second page. I don't know whether you can see the exercise 1. Can you see exercise 1? I don't know what's happening. It looks like it's stuck. Ah, why you are taking control? I don't know. I didn't allow you to take control. No, you didn't. Okay, let me start it over once again. Okay, now it's good. Now it can be seen. Okay, so now we are in exercise 1, the first thing, and we see that from here there are different measurement, right? There are different measurements, and we see that there are three different trials for each of the different measurements. First one is mass of container after adding 20 milliliter water, mass of container before adding 20 milliliter, mass of water. So this is called the result or by deduction. All right. Can see Gabriel still cannot see. Yeah, some Gabriel, I think then it's your connection problem, because others can see. Veron also cannot. Okay, let me refresh it once again. I do not know what's the problem. Oh, ooh, so many considerations. Okay, so I hope you can see now because it looks okay now that it is smooth. Yeah, I muted myself. Sorry for that. Okay, so yeah, I hope that you can see now, right? So there are, for this exercise, for this example, we see that there are, we need to calibrate how we usually do the calibration in the lab of 20 milliliter graduated pipette or pipette at 25 degrees centigrade, right? So we need to calibrate it whether it is having 20 milliliter or more or less how much water is exactly is it delivering disposing 20 milliliter of water or less or more than that. So we need to calibrate in that. So my intention is not to show you the calibration but to show you how to use the significant figures. Okay, so for this, we have 3 trials, as I said, because at least 3 we have to take at least 3 reading or 3 runs. We have to do trials, and for this case, we have done the 3 trials. And for first trial, we see that okay. Before that, how many different units we have here? Can you spot how many different units? We have gram. We have degrees centigrade. We have where is that? We have milliliter. Okay, we have milliliter. So different units we have, and for the different units, we see that there are different ways of expressing the value that we get. The first one is 96.55, right? Second one is 106.31. Third one is 136.11. So there are different number of significant figures. All right, the significant figures are different. Here as well, 25.0. Probably you will say that okay, 0 is 0. Why should we take or consider? But it is considered, and it is considered as a significant figure for this type of calculation. We are going why. So there are different 3 significant figures, 4 significant figures, 5 significant figures we are having here. So at the end, what should we do? How do we deal with all these significant figures? Actually, which one should we take? Should we stick to the 2 or 3 or 4 or 5? What significant figure should we stick to? So this I'm coming there. So the significant figures is very helpful. To express the very big or small number, right? You know the Avogadro's number 6.023 power 10/23rd. That is a so huge number. If we did not have this 10/23rd, right? So we have to write all the things 0023 times 0000. So our life is made easier with this use of significant figures. Or if it is extremely small number, like sometimes the number of moles, right? The number of atoms, number of moles sometimes. Or if we want to consider the number or gram of a virus or bacteria, this weight of a bacteria or virus. So this is such a small number that we cannot have to, 0.000000 in this is so tedious and time consuming and is not efficient. So the significant figures is there. So here you see that it is 0.00000675. We can express it in 6.75, okay, and power 10 negative fifth. So here in this way we expressed in 3 significant figures. Here as well it is 3 significant. And so we are coming there, and that how to know which one is significant, which one is not significant. So the significant figures helps us to express the add, subtract, multiply, all those mathematical operations easily. It helps us to do us easily, at least gives us, I mean, nowadays we have calculator, but at least, I mean, it helps us to have an idea that what the value could be, if even it's very big or small. Like, so for the first operation, we see that 4.31 power 10 negative fourth plus 3.9 power 10 third. So here, we can just add it up, no problem. We use the calculator, it will be just a few seconds, I mean 1 second, it will be done. But to improve our calculation capability, we can also do it very fast and easily, that if we make this 10 power 4 or 10 power 3 on the both sides, right? We make it the same, and then we just add this, the rest, as a simple addition. So in this way, it is easier. So 10 power third, to make it 10 power 4, we have to divide this side by 10, so that this side is gaining 10, right? Multiplied by 10, so divide by 10, so it gives me another 0. So in this way, we make it a 0.39 and 10 power 6. So in this way, we can, I mean, this is the way to do the calculation. We do the calculation in this way. Okay. So here, the significant figures, we are here now. Now, the measurement, the first one, 4.0301 gram, right? 4.0301 gram. Here there are 5 significant figures. 5 significant figures, and it means that if even this one changes to become 2, or this one changes to become 0, right? This one at the end, the last one, the red one in the red, if it is, oh, I have a laser pointer. So this one, if even this one changes 0 or 1 or whatever it changes, it will impact. I will know that this is not the exact same figure. Like I give you, or you give me, or one, what is the expensive thing that I can think of now? Gold. That 4.0301 gram of gold I am giving you, right? And I am taking it back. I want it to be 4.0301 gram, because gold is expensive. I don't want it to be just 4 gram. Then if I just take 4 gram, I am losing 0.0301 gram. Or if even I take 4.030 gram, that means I am losing 0.001 gram. So for the valuable thing, or when we need to be very precise, then this is the uncertainty is more. The highest uncertainty is implied there. For this case, the uncertainty is 0.0001. It's 1 of 10,000s. If even I change one part of 10,000 times, I will know that, okay, it is not the same, right? So this is the thing of significant figures. For however, 50 milliliter, like you are giving a 50 milliliter of a water, or what to say, like a water or milk or any other drink, you are giving to your friend, and you're saying, okay, let's this 50 milliliter, right? Your friend also do not expect it to be exactly 15. He or she knows that, okay, he says 15 milliliter is not 15, maybe 16, maybe 14, right? Maybe 17, maybe 13 milliliter. So this is plus minus 1 milliliter can be, I mean, increased or decreased. Plus minus 1 milliliter can be changes. So that is why it is 2 significant figures, and there is no decimal places after this. But for this 25.0 degrees centigrade, when I say you that, okay, today the temperature is let's say 30 degrees centigrade, Let's say I'm saying this for saying this 30 degrees centigrade. You also know, and I also know that, okay, I'm telling him or her, he also will assume that the temperature is 30, around 30, not exactly 30. Right? But when I'm saying, okay, the temperature is today is 30.1 degree. So you know that there is no question on 30, but maybe 0.1, maybe 0.2, right? So that is the uncertainty or the sensitivity of the data. So the significant figures for this, that is why it is 3, even though it is 0, but here it is important. If this 0 changes to 1 or changes to 24.9 even, this is a big change. It's considered a big change. So that is why this 0 is important, and it is 3 significant figure. For this case, it is 2 significant figures, and this is for the 5 second. So how do we count the significant figure, right? The rule for counting the significant figure is always count the non-zero numbers. Okay, the non-zero numbers, 1, 2, 3, 4, whatever, 15, just now we saw, 20, 30, always count. Everything, all the digits are counted when there is non-zero number. But when the zeros are in front of the non-zero number, these zeros are not counted. Okay, when these zeros, there are zeros in front of a non-zero number, this 1, 5, 6, 3, they are non-zero number, so this 0 is in front, so it is not counted. So here there are 3 significant, 1, 3, 5 is 3 significant figure. Here it is only 1 significant figure for 0.001. Here 0.563, there are 3 significant figures, right? So this 0 is not counted. 0 between 2 non-zero is always counted, but 0 at the end of a non-zero, but since there is, provided that there is no decimal place, that is not counted. So 101 is 3 significant figure, 206, this 0 is not counted, but this 0 is counted. So it is 3 significant figure, not 4. And here is 400 is still 1 significant figure, 2000 still 1 significant figure, because this trailing 0 is not counted. But the 0 after the non-zero is, when it is what do you call it, decimal places, when there is a decimal place and the zeros are trailing, so these zeros are counted. So we all need to count it, although these zeros at the beginning we don't need to count it, but here we should count it, the zeros. Exact number like the pi 3.1416 or whatever, these are not counted. That is not significant figures at the end, because they have a infinite number of figures, so you cannot just count infinity number of significant figures. No, right? So they are not counted as significant figures. Okay, so for an example, if we try to know that what are the significant figures here for the number 1, right? For number 1, the significant figure is, why it is not that? Okay, 3 significant figure, right? For number 1 is 3 significant figure. For a number B, it is also 3 significant figure. For number C, it is not 4, it is 3 significant figure, because the 0 is at the beginning, or at the leading 0. For number D, it is 2 significant figures, because these 2 zeros are before this non-zero, right? For this one, E 1.310, here are 1, 2, 3, 4, because the 0 is at the after this decimal place and after this non-zero, so it is counted. For F 7000, there is only 1 significant figure, because there is no decimal place and this 0 is tailing, so it is not counted. There is another thing that how should we counter or consider, what should we consider when we do the calculation, right, with the significant figures? Like just now I showed here, where is that? The beginning. Okay, here let's say that I am using this one, 96.55 plus 116.31, then 136.11, and let's say that here it is not there, but let's say that if there were anything 19.801, right, 19.80, all together I'm adding, all multiplying together, the result expressed should be the shortest significant figure after the decimal. Okay, here after the decimal all are two significant, two figures, so the final result will be expressed at the two decimal places after this point. Okay, so okay, what I want to mean that if we are taking different number of significant figures together and using this to do the calculation, and among these significant figures there are different decimal places, like one has 2 decimal place, one has 3 decimal place. So when we express the final result, only the final result, what we will do is I will take the shortest or lowest decimal places. Like I have 2 decimal places, 3 decimal places, 4 decimal places, so I will express the result at 2 decimal places only, not 4, not 3. Okay, so that is the rule. All right, and there is another thing that it says that we have to round off, right? We have to round off this if there is more than 5 or 5 after the decimal place, we can round off. But for this there is a rule that if the digit is more than 5, not equal to 5, more than 5, then we can round off. Round off means we can jump to the next stage, next digit, or we can retreat to the previous digit. So here we see that 4.327, since 7 is bigger than 5, so it will become, the 2 is converting to 3 because 7 is bigger than 5. Here in this case 16.249, we could write it, if I had to express it in 3 decimal places, right? Sorry, no, 4 significant figures, because this 16.2 is expressed in 3 significant figures. If I had to express it in 4 significant figures, what I would do is to 16.25. I would just round off, because this 9 be after 4 is more than 5, so I would just round up to 2.5. All right, but since I'm expressing this result in 3 significant figures, what I'm doing is this 4 is less than 5, right? This 4 is less than 5. So since it is less than 5, I cannot round off this 2. I cannot make it 3. It is still 2 because there is 4, not 5. Okay, if the digit is, however, before the last written digit is equal to exactly 5, not bigger than 5, but 5, then there is another consideration. If the last in the odd digit before which one need to be rounded off, if it is an odd, then it will be rounded off. If it is even, it will not be rounded off. See, 3 is an odd number, right? Odd figure. So it is odd number, sorry. 3 is an odd number, so it has been rounded off to 4. But 4 is an even number, so it has not been rounded off to 5. 4 stays as 4. So this is the rule of rounding. Okay, so this is what I wanted to say for this, I mean, for the significant figures. And if we do the summation and multiplication, we see that we will express this result at the smallest decimal places. See 11,254.1, and I'm adding 0.1983. So for the second one, hold on, I have a meeting here now today. Oh my God. Okay. Okay, so the thing is, if I have since I'm using since there is only one decimal place, the smallest one, the lowest one, so the final result is expressed in one decimal place. Okay, not in like 11,254.29 or 298 or whatever, right? It will be expressed as following the lowest number, the decimal places there. For multiplication and division, it follows the same thing, right? So the total significant figure here is 3. 4.51 is multiplied with, is for multiplication or division for both, and this one is addition or subtraction. So 4.51 is the number of significant figures. 3 numbers is significant. The final result will be 3 significant figure as well. All right. So do you have any question about the significant figure now? Is there any question for the significant figures? If not, then I will, what I'll do is, what? Can hear you now. Okay, they both say increase by 1. Yeah, it is, but this is the rule actually. This is the rule. I cannot do anything. Interesting thing is, I will upload this slides today to the Canvas, and there is the YouTube link is given there. So if you want to know more about it, so you can go to that YouTube link. Okay, let me put this YouTube link here. Everybody can have a look. Right? How to? Yeah, here it is, the YouTube link. Yes, 18.35, 18.45. Usually, there is that is not the professional way, but usually we do that, right? Since there is 5 behind it, we just round off to the next level, the next number, right? But the thing is, the rule is, if it is odd, only then you are allowed to round off. If it is even, you are not allowed. So that is the rule. But usually people do that. Okay, so no question, huh? Yeah, please look at the, see the videos. if there is no question more, then I'm going to take this opportunity to finish the tutorial 1, because if I do not finish the tutorial 1, then I have to go tomorrow and take another class. I don't want to do that, so I will finish it quite fast, because I think many of the students has already tried tutorial 1 and they have solved the tutorial. Many of the questions they already have solved. Okay, so what I'm going to do is the first things, those the worked problem that has been solved here, and important formulas and everything. Okay, wait. Stop recording. Right.